Hello everyone. Our topic is landmarking detection with convolution neural network. Since autonomous vehicle is quite popular now, and the landmarking detection is an important task in the autonomous vehicle, there are many sensors can be used to detect the landmarking, but camera is the lowest cost sensor, so we decide to choose the camera to detect landmarking. There are some papers talking about use the neural network to detect the landmarking, such as this one paper. It used the overfit convolution neural network to detect the landmarking and the vehicle in real time. That is the sample for our image that we try to get those landmarking here. In our project, we also use the SynAM model to detect the landmarking. We get the small patch in the image and do the convolution batch normalization and the radioactive function and the maxima pooling several times to get then we use the fully connected layer. Then finally get the output to show whether it is landmarking or non-landmarking. It seems a quite simple model, but it did work well. This is our system, the mobile mapping system, which has two laser scanner and one fleet two camera mounted. That is a sample collected from the fleet 2 camera, and that is a landmarking we want to detect. There is another method to use the segmentation, like just label the landmarking pixel as one and label the other as the other labeling. But that is quite time consuming if you are going to label those things, and also quite difficult since you need tremendous input, tremendous training sample, and it means you also need a lot of image. So we decide to use the other way, just have a small patch, many small patch, then it can increase our training data set and also saving some time. This is the way how we automatically extract the training data set. Just that you know that all the things are done by ourselves. That is one of our contribution. First, we use the LiDAR point cloud that collect from the Veldine laser scanner. You can see that this is the LiDAR point cloud colored by height, and that is colored by the intensity. The landmarking has the higher reflection, so based on that property, we can extract the landmarking and back project them to the image. So in the image, you can see those points are back project from those LiDAR point. Then we can just have grid the image. For the camera, it is 1 frame per second. So for autonomous vehicle, we mainly focus on the current area. Then for the next second, we can just collect the other image. So in this project, we only focus on part of the image instead of the whole image. Then this is our patch size. We just need to keep moving the window and save the image, save the patch image. And if the patch with the projector point, then we will know it is the landmarking patch. If the patch without the projective point, then we will know that is non-landmarking patch. In this way, we have two tests. One is just the rural area, the other is the rural and the highway area. Here is 12,000 patch for the training data set, and here has the 24,000 patch for the training data in the test 2, and that is our sample. You can see that mainly landmarking point and non-landmarking point. For the overall accuracy, we apply the 3 epochs, 1 epoch, 2 epochs, and 3 epochs. And for the test 1, just the rural area, you can see the overall accuracy decrease. Probably it is just overfit the model. For the test 2, it has more sample and a different area, and you can see it's trending quite well. For the third epoch, it already achieved 97.7%. For the confusion metric, you can see for test 1, it keeps decreasing for the mistake that the landmarking tested as a non-landmarking. However, for non-landmarking tested as landmarking, keep increase. But for the tested 2, both of them are decreased. You can see that. So it means it's really improving the result. And we develop our code in the MATLAB environment. So they provided the training monitor plot to see your status. Then here you can see that our training accuracy is quite high in the test 1 and the test 2. Test 2 even better than the test 1. That is our test result. Since previous we just cut the patch, but here we show that if you put the home image there, what will it look like? For the test 1, just the rural area, you can see that some of them are misdetected and some landmarking cannot be detected. Here also there are many misdetected and some cannot be detected. Like this one cannot be detected. That is the input and that is the output to detect the landmarking. That is the tested 2 with the same image. You can see they are same. But the tested 2, the result indeed improved. Like here, just the misdetect 3, but the previous misdetect a lot. And for the highway area, most of them are correct. Just the one are missing. So we can claim that our results with the more sample are the accuracy will be higher. And for the highway area, since the scenery is more simple than the rural area, so the accuracy will be even higher. That is our thank you for listening.